Welcome to online lessons engineering drawing, the continuation of previous one. Now example 6, tetrahedron. Now read the example, note down. A pentagonal prism of base side 30 mm and axis height 65 mm rests on HP on its base such that vertical face is parallel to VP. Draw the projections. Note on this problem. This will be explained with 3D view demo and then the solution in 3D view, how the tetrahedron is available as given according to the problem will be explained.
Example problem 6. A pentagonal prism of base side 30 mm and axis height 65 mm is resting on HP on its base such that a vertical face is parallel to VP.
See the figure. Note on this figure also. In solution, explanation.
Solution to example problem. Draw the simple position front view and top view. Tilt the top view such that the axis is inclined at 45 degrees to the XY line. Draw the projectors vertically upwards from the new top view and horizontally from the simple position front view. Now mark the intersecting points and complete the final front view. Show the hidden edges by dotted lines. Darken the final front view and top view with HB pencil.
This solution is given regarding the example 7. Please note on this example 7 and the previous example 6 as do your own as a homework. Please note down. Once again, this example solution will be explained.
Solution to example problem. Draw the simple position front view and top view. tilt the top view such that the axis is inclined at 45 degrees to the XY line. Draw the projectors vertically upwards from the new top view and horizontally from the simple position front view. Now mark the intersecting points and complete the final front view. Show the hidden edges by dotted lines. Darken the final front view and top view with HB pencil.
This is the final view after example 7. Now we will see the another example, that is example 8. Note down the first problem. Pentagonal pyramid of base side 30 mm, axis length 85 mm, has one of its triangular faces in vertical plane and the axis is parallel to 40 mm above HP. Draw its projections. Note the figure also. Now that will be explained with the solution.
Solution to example problem. Draw simple position front view and top view by considering the axis perpendicular to VP. Keep the base edges equally inclined to XY line in the front view. Tilt the plan such that one slant edge CO is on XY line. Draw vertical projectors from this new plan and horizontal projectors from the first elevation. Mark the intersecting points and complete the final front view. The hidden edges are shown by dotted lines. Now darken the final front view and top view to complete the problem.
This is the final view. This is the final view. Note down clearly. Now the quiz questions. First question. Note down. When tetrahedron is resting on ground on a face, the top view will be isosceles triangle, equilateral triangle, square, none of the above. B. Equilateral triangle. Second one. When cylinder is resting on the ground on its base, the front view will be circle, square, rectangle, square or rectangle. Answer D. Square or rectangle. Third one. When a cone is resting on ground on its base, the front view will be A. Right angle triangle, isosceles triangle, circle, none of the above. B. Isosceles triangle. Now note down the frequently asked questions. This one. Now the next topic is orthographic projections. The next topic is orthographic projections. So in this we may learn projection, orthographic projection, planes of projection, 4 quadrant, 6 faces on the box. So these are the objectives of the completion of the orthographic projections. That is concept of projection of object, orthographic projection and its assumptions, two principal reference planes and the 4 quadrants followed by them, position of the object in different quadrants. These are the objects you may get after completion this orthographic topic. Projection: when rays of sight projectors are drawn from the eye, the observer, and re-extended to fall on the plane of projection, the object is said to be projected. The image obtained is called projection. The size of image depends on the position of plane with respect to object. If plane is kept behind the object, the image size is enlarged. If plane is kept front of the object, the image size is diminished. If the plane coincides with object, true size of object is maintained in the image.
In this video, we are going to discuss about the concept of projection of an object. Consider plane of projection, image, object, and an observer. If rays of sight are drawn from the eye of the observer to the object and are allowed to fall on a plane of projection, the object is said to be projected. The rays of sight are also called projectors. In the next video, we will see about orthographic projection.
Note on the figure, projection of the figure, observer, rays of sight, object, enlarged image.
In this video, let us consider the concept of orthographic projection. It is a projection method in which the rays of sight are parallel to each other and perpendicular to the plane of projection. The image will show the true size of the object. We will discuss about the planes of projection in the next video.
Now we will see the orthographic projections. Ortho means perpendicular. It is a projection method in which the rays of sight are perpendicular to plane of projection and are parallel to each other. In this, true size of object is maintained in a projection. This method is based on certain assumptions. Assumptions are: number one, the observer is at infinite distance from the object. The planes are rotatable. The planes are transparent. Note on the orthographic projections figure. Now, planes of projection. There are two planes of projection, namely horizontal plane HP and vertical plane VP, which are the right angles to each other. The line of intersection of HP and VP called reference line, denoted by XY. denoted as XY. The two intersection principal planes, the projections form four quadrants, namely first, second, third and fourth quadrants. Based on the position of object in the above four quadrants, the method of projection is called first angle projection and second angle projection. Now down the quadrants figure.
Planes of projection. There are two planes of projections, namely vertical plane and horizontal plane. These two planes are at right angles to each other and form four quadrants, namely first quadrant, second quadrant, third quadrant, and fourth quadrant. In the next video, we will see about the first quadrant.
Note on the figure. Based on the position of object in the above four quadrants, the method of projection is called first angle projection and second angle projection. See, note on the figure. Four quadrants. First quadrant. When object is placed in this quadrant, the object will be above HV and in front of VP. This method of projection called first angle projection. Please note down.
First quadrant. In this video, we will see about how an object is placed in the first quadrant. In this quadrant, the object is placed above the horizontal plane and in front of the vertical plane with respect to the observer. In next video, we will see about second quadrant.
Note on the figure also. Second quadrant. When the object is placed in this quadrant, the object will be HV in the above HV and behind the VP. This method of projection is called second angle projection. Note on this figure.
Second quadrant. In this video, we will see about how the object is placed in the second quadrant. In this quadrant, the object is placed above the horizontal plane and behind the vertical plane with respect to the observer. In the next video, we will see about the third quadrant.
third quadrant. When the object is placed in this coordinate, object will be below HP and VP. This method of projection called third angle projection. See the figure and note down. And we will observe that animation also.
Third quadrant. In this video, we will see about how an object is placed in the third quadrant. In this quadrant, the object is placed below the horizontal plane and behind the vertical plane. In the next video, we will see about the fourth quadrant.
Note down the points regarding fourth quadrant. When object is placed in this quadrant, the object will be below HP and in front of VP. This method of projection called fourth angle projection. Note on the figure also.
Fourth quadrant. In this video, we will see about how the object is placed in the fourth quadrant. In this quadrant, the object is placed below the horizontal plane and in front of the vertical plane.
Note down 6 faces on the box. Number of views obtained on the 6 faces on the box. That is top view, back view, left side view, front view, right side view, and bottom view. These are the 6 faces of box.
Six faces on the box. In this video, we will see about how a solid is projected on the 6 faces of a box. A solid is placed in a transparent box and the 6 views of the solid are projected on the 6 faces of the box. The 6 views are arranged by a simple layout.
Note down the 6 faces of the box. Now down the discussions. When object is above HP and behind VP, then it is called dash quadrant, is a second quadrant. When object is below HP in front of VP, it is in fourth quadrant. For true or false questions. Orthographic projection will give true size and shape of the object. True. Next topic is first angle projections. In this, the objectives of this one, on completion of this topic, you should be able to know principle of first angle projection, method and its layout, principle of third angle projection, method and its layout, symbols for first angle and third angle projection methods, second and fourth angle projection, and why they are not used in practice. Number of views required to completely specify the object. These are the with the recapping of this one, you may learn first and third angle projections. Note on the first angle projection, layout, setup, observer, object, plane of projection. This should be not violated. Front view, elevation, projection of an object on vertical plane, top view, plane, projection of object on HV, side view, projection of object in an auxiliary vertical plane. Now note down the views: front view,
First angle projection. In this video, we will see the complete concept of first angle projection. In this projection method, the object is placed in the first quadrant. The setup is observer, object, followed by plane. This should not be violated for projection of any view. The front view is projected onto the vertical plane. To draw the top view, look at the object from the top and check the setup. Now project the top view on horizontal plane. Rotate the horizontal plane through 90 degrees and keep it in line with vertical plane. The top view comes below front view. To get the left side view, look at the object from the left side and again check the setup. Now the setup is observer, plane, object. This is a violation. Therefore, keep the plane beyond the object to get the correct setup. Now project the left side view to the auxiliary vertical plane. Now rotate the auxiliary vertical plane through 90 degrees and keep it in line with vertical plane. The left side view comes to the right of front view.
And note down the figure. First angle projection, front view, top view, and by the side, front view and top view. Layout. Front view can obtain in a vertical plane, can be represented in plain sheet of paper. Top view can obtain in the horizontal plane, and by rotating HP through 90 degrees clockwise, it will come in line with vertical plane and below it. Front view will come above XY line and top view will come below XY line. Left side view will come to the right of front view. Similarly, right side view will come to the left of the front view. Note on the views. First angle projection layout views. Note on third angle projection. In this method of projection, object is placed in the third quadrant. Set up observer, plane of projection, object. This method not violated. This should not violate it. Front view, elevation, projection of object in a vertical plane. Top view plane, projection of object on HP, horizontal plane. Side view, the projection of object in a auxiliary vertical plane, AVP. Note on the figures also.
Third angle projection method. In this video, we will look into the concept of third angle projection method. In this projection method, the object is placed in the third quadrant and the setup is observer, plane of projection followed by object. We have to assume that the planes are transparent. Now, the front view is to be projected onto the vertical plane. Now, to get the top view, look at the object from the top and check the setup. Now, project the top view in the horizontal plane and rotate the horizontal plane through 90 degrees clockwise and bring it in line with vertical plane. Therefore, we are getting the top view below the front view. Now, to get the left side view, look at the object from the left side and again check the setup. Now, the setup is observer, object and plane of projection, which is a violation. Now, correct the setup and then project the left side view onto the auxiliary vertical plane. Now, rotate the auxiliary vertical plane through 90 degrees and bring it in line with the vertical plane. Therefore, left side view comes to the left of the front view. A violation. Now, correct the setup and then project the left side view onto the auxiliary vertical plane. Now, rotate the auxiliary vertical plane through 90 degrees and bring it in line with the vertical plane. Therefore, left side view comes to the left of the front view.
Now note down third angle position. Layout. Front view is obtained in the vertical plane, can be represented in a plain sheet of paper. Top view is obtained in the HV by rotating HV through 90 degrees clockwise. It will come in line with VP and above it. Front view will come below XY line and top view will come above XY line. Left side view obtain an auxiliary vertical plane, and by rotating auxiliary vertical plane through 90 degrees, it will come in line with VP to the left of it. Left side will come to the left of front view. Similarly, right side of view will come to the right of front view. Now note down third angle position figure, layout figure.
Symbol for first angle projection. In this video, we will see how to get the symbol for first angle projection method. Consider frustum of a cone and draw the front view and left side view for the frustum as per first angle projection method. In first angle projection method, the left side view will come to the right of front view. Now this is the symbol for first angle projection method.
Note down
Symbol for first angle projection. In this video, we will see how to get the symbol for first angle projection method. Consider frustum of a cone and draw the front view and left side view for the frustum as per first angle projection method. In first angle projection method, the left side view will come to the right of front view. Now this is the symbol for first angle projection method. At this we will end. Continue in the next class.